Welcome back, learners. Welcome to my F5 IPDNS 302 complete study videos. We are in the chapter 4. Learners, this is a very important chapter because we're going to cover all the lab scenarios. So far, we have covered so much theoretical concepts. Now, in this chapter, we're going to cover the practical and the lab scenarios for whatever design we have discussed. So just to recap, in chapter 1, we discussed the basics of DNS with lab. We discussed on the TMOS understanding of F5 DNS. We discussed on the basic TMOS concepts, how we can license the F5 box and the relation between the TMOS and the DNS architecture. Then in chapter 3, we did a deep dive into the F5 DNS concepts. We gone through some of the design considerations of F5 DNS. Now in chapter 4, we're going to do the lab part, and chapter 5 would be test and troubleshoot of the IPDNS, and chapter 6 we would cover the exam review of all the topics that we have covered. All right, learners, so let's go ahead. Okay, so in this video, I'm going to cover the lab overview. I'm going to cover these 3 scenarios. It's lab part 1. Lab part 2 would be succeeded after this video. So we're going to cover these 3 scenarios. Scenario 1 would be having the 2 data centers DNS in a sync group, adding the LTMs to the IP DNS, setting up F5 IP DNS, wide IP and authoritative DNS for the test5.com. All right, learners, let's begin. All right, so before that, let's have a lab overview. Okay, learners, I have created this lab in EVNG. If someone is interested in learning how to design this lab, they can just comment me. I can have a separate video for that. But for now, I will not cover the entire lab setup. I will only cover the DNS concepts that's needed, the DNS scenarios that's needed as a part of this lab overview. Just to give you a high-level overview of what my lab design is, I have created 2 data centers, data center 1, data center 2. My data center connectivity is for my test F5 organization, and I have 2 DNS. I have a pair of LTMs in data center 1. I have a pair of LTM in data center 2. So I have SSH telnet servers. So the LTMs would be load balancing this telnet servers, and I will have a wide IP configured here at the DNS that's going to load balance between 2 data centers, and these 2 GTMs or the IPDNS would be in a sync group. They both will have the same configuration objects. So I will create basically 2 wide IPs, learners. One wide IP load balancing the LTM VIPs, and one wide IP pointing to a generic host. We need to cover both scenarios, generic host and the big IP products, right, as part of the design. And finally, this is testf5.com authoritative name server, learners. So my main domain, testf5.com, is hosted here, and F5 DNS would host gslb.testf5.com for its wide IP. I have created a remote client setup. The client would be in a fastnet domain, its own different domain. The client is connected to the LDNS, and LDNS is hosting the fastnet domain for the client. And this LDNS, it will forward the testf5.com to the testf5 authoritative name server. I will show you the configuration part, learners, but I will not show how to configure in detail. If anyone is interested to let me know, I can have a separate video for that. Okay, for now, let's try to understand at the configuration level. As I said, data center 1 VIP, the VIP IP is 100.1.1.20. Data center 2 VIP would be 200.1.1.20. So basically it would be load balancing these two servers in data center uh, 1, sorry, ignore this typo. Server 1, data center 1, server 2, data center 1. Let me make this change right away. Okay, and the data center 2 web would be load balancing server 1 of data center 2 and server 2 of data center 2. So these are basically routers, learners. The reason why I configured router as server is because I'm creating a telnet web. Let's show you the configuration. These are already some part of pre-configured learners, but what we are going to configure is this thing. We're going to configure the sync group as a part of this lab. Okay, so let's have a quick overview. Okay, so let's check on the LTMs learners. So if I go to okay, let's have a GUI part here. So I'm logging into the LTM1 of data center 1 GUI. I'll just show you what configuration object I have there. So this LTM and LTM2 are in sync group, and it is pre-configured with the telnet web 100.1.1.20. That's what I have shown here. And as a site, it's having a pool of 10.1.1, 10.1.1.2, 23. So these are the pool members. Okay. Similarly, let me log into the GUI of the LTM1 of data center 2, and let's review the configuration objects there. Okay, data center 2, LTM, okay, DMSH list. So this is the DMSH command line that's normally used to view the management IP. So you can use this on LTM or on GTM. So I'm now logging into data center 2, active LTM. I just want to make sure that it has the necessary configuration object that would be needed in the wide IP. Okay, so if I go to virtual, it does have 200.1.1.20, so that's pre-configured. If I go to network map, you can see the pool members 20.1.1.1 and 20.1.1.2 are the its pool members. Perfect. Okay, learners, so pre-checks on the configuration objects of the LTM is done. Now let's try to log in. Our first task, let's revisit the first task again. What we're trying to do, we're trying to configure data center 1 and data center 2 DNS in a sync group, which means we're going to create a sync group for these two DNS. Let's log into the box, learners. I'm not sure if something is pre-configured there, but let's try to log in. So its management IP is this. Let me log into the GUI. I normally use GUI because that's the most familiar way to understand things. So this is my DNS1. Okay. Now let me log into DNS2 as well, GUI. Okay, this is the management IP. Okay. Okay, so as you can see, the host names are created, some pre-configuration is done on this GTMs. I'll show you what pre-configurations are done. I've just configured it in the interest of time. If you start building from scratch, it may consume a lot of time. So I've configured the host names, DC1 F5 DNS, DC2 F5 DNS. I configure the self IPs. I configure the self IPs. All right, I configured 7115 as a self IP here, and here, okay, I'm yet to configure self IP here, so we'll do that later. We need to do it right away. Hold on. Because if you're trying to create a data center, okay, let's try to create a data center in both GTMs first. So how do you create data center learners? So we visit, you log into the box, you visit the DNS section, you go to the GSLB, click on data centers, and I do not see any data center created. Okay. Similarly, on my data center 2 GNS, I click on GSLB and I click on data centers, no data center is created. Okay. So learners, the question, how many data centers I need to create here? Okay. I need to create 2 data centers. Okay. I need to create data center 1. I need to create data center 2. Or let me do one thing, learner. I mean, this can be a good learning as well. So I will create data center 1 completely, and I will add data center 2 to the sync group of data center 1 and try to pull configuration. I think that will solve a purpose of this GTM add script, because if we try to configure both from the scratch, then we will not be able to understand the config sync. So let's leave the data center 2 as it is. We just need to create the networking objects. I will not create anything under the DNS in data center 2. Everything is going to be pulled up as a part of the sync group. Okay. The only thing that I need to create here is the self IPs learner. If I check, the self IPs is created here. The VLANs is created here. Okay. Similarly, I will be needing to create the VLAN and the self IPs. Okay. So if I go to my lab diagram, I can see F5 DNS VLAN is this, and the VIP VLAN is this. Okay, so okay, so I need to create this DNS VLAN and the tag. Okay, let me just log into this core router. I will be getting the details of the DNS VLAN. I'm logging into core router, DC2 core router learners. H show VLAN brief, and if I check what is the VLAN for Ethernet 0 by 0, Ethernet 0 by 0, that is the GSLB, so I need to tag it under the VLAN 80. Okay, and if I check the IP for VLAN 80, it's 80.1.1.1, so I need to create like 80.1.1.5 here. Okay, learners, so let's go ahead and do that. Create VLAN. I'll be creating VLAN 80. Oh, sorry, I can just try give it a name, more logical name like GSLB VLAN, I'll give it a tag of 80. And on the F5, it's Ethernet 1.1. So it would be an untagged because it's not a port channel. It's a access port kind of thing. And I click on finish. VLAN is done. Now I'm going to configure the self IP, create the self IP name GSLB underscore self IP 80.1.1.5 to 55. That's correct. GSLB VLAN port. I will be allowing default Linux. Ideally, you can do a port lockdown. You can create a custom port lockdown, and you can allow the iQuery and the remaining port things. But for now, for convenience of this lab, we're just going to allow the default, and default allows all the necessary communication needed for GTM to GTM and GTM to LTM communication. All right. I'll be creating non-floating. We don't need a floating IP because these are the standalone GTM boxes. So I'm done with the basic network configuration learners. I do need to configure. Let me check here listeners as well. Okay. All right. Learners, if you remember, theory, we discussed the importance of listeners. So once you configure the networking thing, the very first thing you configure on a GTM box is a listener. A listener is an object that listens for DNS query learners. If you don't configure listener, your GTM box is of no use. Okay. So let's try to create the listener in a very similar line what we have done here. TCP name, I will give the same name. This is my data center 2 learners. Okay, it would be 80.1.1.5. Oh, it's a TCP listener. I don't think we have any iRules. No, there's no iRule. Remaining all default. Similarly, I need to create a UDP listener as well. UDP listener destination 80.1.1.5 UDP blah blah blah. Remaining, I click on finish. Okay. All right, learner. So we have configured. We did some pre-configuration on the DNS2, and we're not going to configure anything else because we want DNS2 to be a fresh box, and we will introduce that to the existing sync group, and DNS2 will pull the configuration from DNS data center 1. So for that matter, let's try to build the DNS data center 1 first, learners. Okay. So the DNS data center 1, it will have. Okay, so what all needed in the DNS data center 1? We need to create the server objects, learners. Okay. By doing this, in fact, I'm also configuring 2 and 3 simultaneously, learners. So what I'm trying to do is I will try to create 2 data centers. I will try to create a DNS server object for this DC2 DNS. I will try to create LTM server objects for data center 1 and data center 2. All right, so let's do that. First, let's do data centers, create data center 1. Sorry, location ABC. I don't care what location is that. And I want my data center to be enabled state. Yes. Now I'm creating data center 2. I don't care what location it's that. It's just a lab. We have the liberty to play around with the lab scenarios, learners. So the state is enabled. So I'm done with. All right. So I'm done with creating data center. Now I need to create the server objects. How do we create that? Go to GSLB, data center, beneath data center, the servers. I'll create the first server object, and the first server object would be my GTM2. Okay, I'll tell you the reason, learners, why we're creating an iQuery full mesh, okay, for the sync group. So if you don't create GTM server object, these two boxes will not be in a sync. So the very important thing, or the very first thing that you create in a GTM server object is your peer GTM boxes. Then we need to add the LTM boxes. Okay. All right. So let me just copy the name here. We'll be adding this. That's data center 2 DNS. Here, when you create the server objects, you have an option to select the big IP product. Since it is a big IP, I'm selecting it as big IP product. I can even add a generic host. I can even add third-party load balancers. We discussed this, learners, in theoretical classes, that what products we can select. But for now, since it's a big IP product, I'm adding a big IP system. Now this is in data center 2, obviously. Prober fallback. Okay, we will discuss on the prober pool later on, learners, once we are done with the basic setup. Now let's try to add. Okay, device name. I'm gonna add the same device name, copy paste here. Okay. All right, learners. So what address we are going to add here while we are adding the server objects? It's very, very important. We are not going to add any management IP here. We need to add the self IP. Okay. So for the iQuery connection, we are not using management IP, learner. That's a rule of thumb, because your iQuery will not run on the management IP. So I'm adding the self IP. I'm not using any translation, so this box will remain blank. Link is auto select. It doesn't matter. It's by default auto select. Click on add. Okay. And health monitor, it's the big IP, learners. We have checked the big IP monitors all the server objects. Virtual server discovery is disabled. It's a GTM. We don't want any virtual server from the GTM to be discovered here. And we click on finished. Okay, but for that, let's we click on finished. Okay, so we are done with this, learners. Now next thing, we are going to add this LTM pair of data center 1. So how do we add this? Okay, if you're adding a standalone, it's different, but here if you're adding a pair, you can add as a big IP system devices. Okay, I'll tell you how to do that. Okay, since first is data center 1 F5 DNS and data center, sorry, my bad, data center 1 F5 LTM1 and data center 2 F5 LTM2. These are in active standby. So we need to select a common name for the common here is data DC1 F5 LTM is the common name for both active and standby. So I'll choose that and I will put that as a name. This product is big IP. This is data center 1, learners. These are the data center 1. Probo preference, probo fallback. For now, let's keep it as inherited from the data center. We will configure probo pools later on. State is enabled. Now again, device name. Here we explicitly put the device name, learners. Here for LTM1, I will put the LTM1, and the address again, it would be the self IP. DMSH listnet self Let me check what self IP I need to address here. So learners, if we check here, my server VLAN is 10 and my external is 100. So we'll try to add, because this 10 self IP may not be reachable to the DNS box, because this is internal to this server and the iQuery will fail. So I will try to add the external VLAN self IP so that my iQuery will be succeeding. Okay. So what is that? The self IP is 10. Okay. Learners, if you see the configuration, 12 is my floating, 10 and 11 are my self IPs. Let's go ahead and add 10 for LTM1. I'm not using any translation. I simply add bat. 1 minute, but just need to click on OK. Now again, I need to add for data center 2, sorry, data center 1, LTM2. Now the address is 100.1.1.11. Right, 10 and 11 are the self IPs, right? 10, okay, 10 and 11 are self IPs, no translation needed. Simply click on add. Okay, so this server object is since it is having two big IP systems, it's in a HA pair, right? If it's standalone, you just add only one big IP device. Okay. Health monitor is big IP, and virtual server discovery. I want the virtual server to be discovered dynamically. I click on finish. Okay, so now we're gonna add the now we are gonna add the third server object, learners. That would be the HA pair of data center 2. Okay. So how do we do that? We take a common name, data center 2 F5 LTM. Okay, we'll make a common name. Big IP system, that's true. It's in the data center 2. Probo, we'll talk about Probo pool later. Click on add. Oh, now we will add the specific individual host names. The self IPs, let's check what self IPs it has. The external self IPs. Net self, one line, sorry, bad command. External is 200.1.1.10, I guess. Yeah, 10 and 11 are its self IPs. So I'll add this. No translation. Can add quite easily. Click OK. Add and one more. 11 DC2 F5 LTM2. No translation. I'm going to add this. So I've added two LTMs in HA pair and the data center 2 F5 LTM group. And I'll add big IP as the monitor. I will need virtual server because I want to dynamically discover. So this option, learners, it will do a dynamic discovery of the virtual servers on this HA pair. If you don't enable it, you have to manually add the virtual servers under this server object. I will let you know what I meant once the whips are discovered. I'll click on finish. Okay. So as you can see, learners, my data center 1 LTM group is already up. And if I just go, okay, I see, all right, okay, I see the LTMs are up, okay, but I'm not able to discover the virtual servers, learners. Let's troubleshoot. If you recall, I said that I configured 100.1.1.20 in this LTM pair, and I configured 200.1.1.20 in the data center 2 LTMs. So even after enabling a dynamic discovery of the LTMs, why I'm not, let's give it some time, learners, okay? Let's see it again. Oh, 200 dot, okay, in the data center 2, it's not even being discovered. Let's see what's wrong there. So this is what, learners, the lab is pre-configured, but if there is something that we need to correct at the routing level, we can do it. I can just explain you. I've kept the routing very simple, learners, because our intention is not to set up a routing lab. Rather than we have to set up a very understandable big IP DNS lab. So if you talk about the routing, the service, I have three routing domains here. First routing domain for data center 1, second routing domain for data center 2, third is our service provider. That's having a full route, that establishing a full route connection between data center 1 to data center 2. At the same time, the same service provider is connecting my client network as well. So all these three locations are in different autonomous systems. In the service provider, only BGP is running. In the data center 1, I have a OSPF, and at the edge router, it is being redistributed to BGP. Similarly, you have a OSPF within the data center. At the edge router, OSPF is redistributed at BGP. Quite simple. Okay, so my concern here is okay, why the data center 2 LTMs are. Let me check the reachability, learners. Okay, this is my data center 1 DNS. If I ping here, multi-reach, telnet. Okay, even iQuery is working. So what is the problem? The problem maybe ping to 200.1.1.20. If I do a telnet to this, I should be able. Okay, it's not a telnet. Okay, telnet routers. I should be able to log into one of the routers of the data center 2 that's being load balanced. So learners, I think I discussed what these servers are. Servers are essentially the routers with telnet functionality. So if I do telnet to the web on the data center 2, it should be connecting to one of the router with IP 20 on this data center 2. It can be named as server 1 or server 2 of DDC 2. If you want, I can check that. Password required. Okay, there you go. So connected to server 1 data center 2 on this web. Web is my front-end IP. I'm connected to server 1 data center 2. Let's gonna exit. So why my data center is not coming up? I need to check that, learners. Oh, okay. I think there is one issue here. Okay, one issue I've found it, learners. So when we create a server objects, for GTM, we do create a server object for the self GTM. In this case, I need to create one more server object with DC1 F5 DNS learner. So if you don't create the server object, what's going to happen is it's not going to your GTM your GTMD is not going to talk to your local big 3D, and that may impact the discovery of other big IP server objects. So let's try to create, yeah, let's try to create own data center DNS. Okay, so this is my own data center, own GNS DNS box. Sorry, big IP product data center one, inherent this. Okay, so what is the self IP? It's device name. I can give a FQDN. Self IP is 70.1.1.5. We already checked the self IP on this. GTM, no translation needed. Okay, monitor big IP at a very basic level. We only do these configurations. Okay, so let's check the servers now. Okay. Okay. Oh, oh, there you go. There you go, learners. So I can see. Okay, I can see two virtual servers are auto-discovered. If you check, I did not added this virtual server manually. Wonderful. So my DNS and data center one is auto-discovering the virtual servers of the LTMs in data center one. But still, I see an issue with the servers 2. I mean, the data center 2 is not still coming up. What could be the reason? Mm, let's do the IQ dump, learners. Okay. Okay. I think I know the issue. Learners, okay, my bad. I should have told. So, I have added I need to add this big IP add script, right? So, on this GTM, I previously added, if I remember, I tried to set up the data center one, and I previously added the big IP add script, learners, for these two LTMs. And that's the reason, even when I deleted and tried to re-add, I could discover these two LTMs. But I've not added the LTMs for data center one and data center two LTMs. And that's the reason I don't see them being discovered. I can see the same in the IQ dump. So let's see. This is my data center one DNS. If I do IQ dump and I try to issue the self IP there. Okay, so you can see it's not even initiated the call actually because I have not exchanged the certificates. DMSH show GTMI query. So this can be a very handy command, learners. Show GTMI query to understand what server objects are connected and what are not connected. So as you can see, the self DNS is showing us connected. This is my LTM1 and the data center 1. It's showing is connected. This is my LTM2 and data center 1. It's connected. I've configured the server object for data center 2 LTM1. Server type unknown, it's not connected. I've configured LTM2 data center 2, it's not connected. So let's try to add the big IP add script, learners. So we're trying to we're trying to do the 2 and 3 tasks similarly, learners. Okay, so I'm adding big IP add script. Okay, big IP add script to add the two LTMs of data center 2. They have the network connectivity, they have 4353, the ports are open, they have the SSH telnet. So two things that's needed, learners, for the iQuery is port 4353 and port 22. So if ports are open, these two ports are open, then I can fully establish the iQuery. Okay. So let's configure it. Big IP underscore add root at the rate what's the IP? 200 1.1.10. Okay, learners. So since we are adding the big IP, this is the syntax. We already learned about the syntax in our previous theoretical chapter. So this is the syntax. We give big IP underscore add. We use the root command. So whenever you're trying to add a LTM to a GTM, you need to know the root credentials, learner. Without root credentials, you cannot add the LTM to the GTM. So big IP underscore add, then it will try to connect. Yes. And you should remember the root login. Okay, done. Similarly, I need to add the LTM2 of the data center 2 in the DNS of the data center 1. It's 10 and 11 learners. Okay, yes. I'm hoping I'm putting in a correct password. Okay, now let's again show the GTM iQuery. Okay, 71.5, my local DNS of data center 1. It's connected. 8115, this is unknown. That's quite understandable because I've not configured the data center 2 DNS. Okay, 101.110, this is my data center 1 LTM1. It's connected. 101.111, my data center 1 LTM2. It's connected. Perfect. 201.110, my data center 2 LTM 1. It's not connected. 201.111, my data center 2 LTM 2, still not connected. Okay, should we give some time? Maybe it might take a while. Let's try to. Okay, learners. Perfect, my data center 2 is up. I think if I check the iQuery, I should be able to see them connected. Yep. Sorry, my bad. 101.1. Okay, there you go, learners. So what all you can see in the iQuery, show GTM iQuery. So this can be a very useful exam question as well. In show GTM iQuery, you see the destination, you see the connection state. It's very important. You need to make sure that it is connected. You see the server type. If it's a big IP product, it's a big IP, or if it's a generic host, you cannot run iQuery on a non-big IP product. iQuery is a very big IP protocol. Okay. Then what else? You can check the local big 3D version, and you can check the remote big 3D version. So we discussed at length on the versioning of the big 3D. We want to make sure the big 3D is same in the synchronization group and in the peers that are communicating with the iQuery. Similarly, LTM2 and data center 2 connected. Perfect. I think we are done. If I do refresh it again, perfect. And even I can see two virtual servers on the data center 2 are being discovered. C learners, so 200.1.1.20 and 7.1.1.10. These are the two virtual servers configured in the LTM pair of data center 2. They are dynamically discovered. So far what we did, okay. So far, we created a data center, we created the server objects, we couldn't use the GTM add script as of now. I'm gonna do that when I will try to add the GTM2 here. Test and validate, we did a partial completion of this test. We validated the LTMs are connected. In this part, we created the server objects for the LTM of data center 2 and data center 1. With the help of big IP add, we added the LTMs of data center 2. Remember, LTMs of data center 1 we previously added with big IP add script. Hence, even when I deleted and tried to recreate, re-add them, it didn't ask for a big IP add script. And we tested and validated. So this task is completed, learners. Okay. Now, let's try to add the GTM to a sync group. So this is very important, learners. So how you add a GTM to the sync group, okay? So before that, let me assure that I have all the necessary server objects. I need to create two server objects for two data center, and I need to create two server objects for two data center LTM groups. There is one more server object. Okay, let me create that as well, learner, because if you check the topology, I need to create one generic host as well. Okay, then what is a generic host? Let me just try to log into data center 1 core switch. I've created one loopback interface, learners, and I will use that as creating a generic host. Okay. Let me check. Okay. Right to okay. This data center 2. Okay, rename. Sure, IP interface brief. Okay. Okay, we did not bother about this log for now, learner, because I tried to establish a BGP peer, but I believe that BGP is down on the big IP load balancer. We're not going to do this this part as a scope for this lag. Let me just try to stop this logging. Yeah, I think no logging console. This is a very Cisco command. Okay. All right, learners. So I tried to create 23. Okay, let's use this as a generic host 23.1.1.10. Okay. So I will create a generic host, learner, with 23.1.1.10. This is nothing but a loopback 3 on my data center 1 core router. So I'll try to create a wide IP or the DNS mapping to the loopback, one of the loopback of the DC1 core router, so that if I try to log in with the DNS name, it should connect me to data center 1 core router. Okay, how to do that? So we learned how to create a big IP product server object, learners. Now we will be learning how to create a non-big IP product servers. Process is same, GSLB. Under data centers, click on servers, click on create, and you can name here as data center 1 generic host server. Okay, something like that. Product, I will be selecting generic host. Okay, and this is the address 23.1.1.10. No translation is needed because it's not in the behind the NATO firewall. I click on add. I'll select it under data center 1. It's not needed for now. It's not needed. I will leave that as default. I will not select the health monitor for now, learner, for this generic host. And here again I have to add the same thing under the virtual server. Okay, so I'll just give it a name, and address is this, service port 23. So there are two sections, learners. So in the first section, when we are defining a server object, here we are defining the server object. We just need the IP address. We don't need the port, service port. In the resources section, we are defining the virtual server, so we would be needing the service port. So I will use this telnet port here for now. No translation needed, no translation port needed. Click finish. That's it. So it should come up. It should come up shortly. Should come up shortly. Let me see if this is pingable. Yeah, if this is pingable from my should be reachable actually. Yeah. Okay, I think I know the issue. Again, I just try to over assume few things, learners. So over assumption and realizing is a part of good learning. Okay, you over assume something, you realize that you're wrong there, again you go back and you learn. So I think I need to create the monitor here for the virtual servers. Okay, so this is where I went it wrong. So I will do a gateway underscore CMP. Now it should come up. Give it a few time. Server. No, not this, not this. Am I looking at the incorrect part? Should be looking at here. Okay, virtual server. Oh, there you go. It came up later. Right, so if we're done with this generic host, let's see if you have a generic host in the data center 2. I'm sure I did have a loopback configured specifically for the generic host. Okay, I would be using 33.1.1.10 of data center 2 as a generic host here. Okay, I'll be creating one more data center 2 server data center 2 GH generic host server. I'll just give it a very simple and relatable name. It's generic host. Address is this. No translation needed. Simply add data center 2. Then what I need here, gateway ICMP is the health monitor. We learned from a mistake. We need to have the health monitor here. Under the resources, I will use the same name, and the IP is same. Service port, it's a telnet service port. I will telnet to the router of data center 2 core router learner. No translation needed, no translation port. You normally use these fields if the server object is behind a firewall, which is not in our case now. Click on add, finish, and let's give some time. Data center 1 is up. Let's do some quick check actually. I'm sure I configured everything. The routing is configured to be reachable. Yep, I can see. I can ping the server object from my data center 1 DNS, so my routing is good. Server again. There you go, learner. So my generic hosts are up. It now looks a good server objects now. I have 1, 2, 3, 4, 5. 5 server objects are up, but this part will not be up until I configure the data center to DNS. So learners, there is one more way to check if the iQuery and the server objects in the statistics, right? Go to stats, go to module stats, under DNS, go to GSLB, okay? Here it just gives a very high level overview. I didn't configure any wide IP. I indeed configured 2 data centers. I have 6 server objects created, 5 are up. Out of the 5, 3 are big IP and 2 are generic host. 1 is offline. Okay, so here if I want to check the iQuery, right, I can check it here as well, learner. So instead of doing show IP, show GTM iQuery, if someone is not familiar with this command line command, they can also try to have a look here. Okay, and iQuery is, as I said, it's a big IP proprietary protocol, so you can see the iQuery to only the big IP products, not to the generic host. We don't need iQuery monitoring for the generic hosts. Okay, learners, so we are done with this. Now we are into the part 3 here. Okay, we're not going to create a wide IP, learners. Okay, let's try to create wide IP on the, we'll create everything on the DNS1, and we'll try to sync all these objects in DNS2. Okay, so we're gonna create 2 wide IPs. I mean, if we check the original plan, the plan is to create 2 wide IPs, test web and test web generic host. The first test web is going to load balance the WIP IPs of DC1 and DC2. Okay, so how do we do that, learners? Learners, before we create wide IP, we create the pools first. Okay, so what I'm going to do is I'm going to create 2 pools, learners. So one pool would be for data center 1 and one pool would be for data center 2. So I'm going to create pool 1, pool DC1. It's a record. I'm not using any IPv6. So the pool will ask which record of WIPs are using. I'm using a record WIPs. Health monitor I need not explicitly mention here. By default, it's taken the big IP health monitor. Okay, and for the simplicity, I would be using a round robin load balancing method here, because I will have only one WIP for data center 1. Pool DC1, I will have only one. So what I need to select here, I need to select the DC telnet WIP, right, for data center 1, DC1. Okay, I will add and I will get it finished. By default, it's taking as ratio, but doesn't matter, test lab, we just have only one virtual server object. Now I will create pool DC2. It's a record. state is enabled. I need not configure the health monitor here. Load balancing is round robin. The virtual server that I'm going to select is data center 2. Yep, data center 2. Okay, so we discussed on the two levels or the tiered load balancing learners, right? So this is the load balancing applied at the pool level. Okay, so if we just refresh it again, I should be able to see both the pools. Okay, so we configured pools. We went to GSLB, wide IP, below wide IP, we'll configure the pools. So pools are up. Now our next part is to create a wide IP learners. We're going to create two wide IPs. Okay, well, I think I need to create a pool for generic host as well. Okay, if we create a pools for the LTM objects, I'll create one more pool. Pool data center 1 generic host. Okay, it's an A record. I will not configure in the health monitor at this stage. I will leave everything as default. Let it be round robin. And what I'm going to select here is the generic host, data center 1 generic host. Okay, now finished. Now again I'll create pool DC2 generic host. It's a record. I'll not select health monitor here. The load balancing, everything is default. Data center 2 generic host. Add and finished. Okay, learners. So if I again refresh the pool section, perfect. So I have two pools, load balancing the LTMs, and two pools, load balancing the generic hosts. Now I have everything prepared to create the wide IP learners. So I'll go ahead and create the wide IP now. Create, and the first wide IP name that I'm gonna give is test. Okay, no issues. So this is my first wide IP that's gonna load balance the LTM pools across data centers, and this wide IP will load balance the A records. And it's not mandatory to give description. You can leave this blank. I'm not creating any iRule for the wide IP. You can create iRule in the advanced configuration if you really need. Now at the pool level learners, what I would like to, I've already discussed what load balancing method we have at the wide IP levels. We only have 4 load balancing methods. It can be general availability, it can be ratio, it can be round robin, it can be topology. We will have a separate lab for topology learners. That's very interesting as a part of their 5 IP DNS exam point of view as well. But for now, I'm going to put it at general availability. General availability, as you know, it does active standby load balancing. What it primarily does it will send all the traffic to the pool 1 first on the order 1. Okay, only when the pool 1 of data center 1 is down or data center 1 is down, it's going to redirect the traffic to data center 2. Okay, so let's use the global general, sorry, my bad. It's a global availability. I keep on calling it general availability, my bad. And in this, I will add pool data center 1 in the order first and pool data center 2 in the second order. I'm not creating a last resort pool. We discussed on the last resort pool earlier. Okay, I'm leaving everything else default, and I'll click on finish. I'm created one wide IP for the LTM web learners. Now let me create the second wide IP for generic hosts. Okay, so I'll just try to use this name. I'll just modify it with GH for generic host. It would be load balancing A records. I will leave the description to default. State is enabled, no I rule. Load balancing method again, global availability pool. I'm going to select DC1 in the order first, since it is global availability. DC2 generic host pool in the second order. Okay. Click on finish, learners. So I'm done. Okay. Perfect, learners. So my now VIP is ready. My wide IP is up. So what have we done so far? We have configured TC1 data center. No, this is not yet done. We are going to do the sync group now. I've configured data center 1 at list completely, added the LTMs to the IP DNS, set up the F5 IP DNS wide IP. I will talk about this a bit later after I do the config sync. Okay. All right, learners. So my F5 IP DNS is ready for data center 1. And data center 2, I just need to oops. Okay, learners, I think one thing I'm forward here, I need to add this GTM in a sync group, right? Currently it's in a standalone mode. How do I add it in sync group? So again, go to DNS, go to the settings, go to GSLB, go to general. Just make a note of the steps. Here, the very important thing I need to check mark is the synchronize. Okay, when I'm adding a GTM in a sync group, I click on synchronize. I have my tube name as test F5 from default. I change it to test F5 from default. Okay. TLS minimum version is V1. I can even select V2, V1.2 in fact. Okay, let's select 1.2, or we can leave it for default. Auto discover, I enabled it. Heartbeat 10 seconds, and I will leave the remaining fields as it is. Forward status. Okay. Where do I see that? Okay, this is very important, learners. So we discussed on the importance of synchronizing zone files. So normally we check this box. We want our zone files to be synchronized between both the data centers ETMs, or if we have any intention of creating one as master, another as the slave DNS architecture, we need to check this box. So I'm checking this synchronized zone files. And the other things, forward status, I will not check at this point of time. So the virtual server status, I have 3 options, learners. I can either say it depends on monitors only, or I can say it depends on servers and monitors. Okay, so based on that, the virtual server status would be reflecting on my GTM. So leave everything as it is, default. I click on update. All right, learners. So my DNS1 is in a sync group. If I go ahead and issue a command in the CLI, attribute list, list GTM global settings general. Okay, you can see the synchronization is yes. Okay, learners. Now what to do? Now I have to make my DC data center 2 DNS to sync with the data center 1 DNS. Okay, so the rule of thumb of synchronization is I will do a GTM add script on the F5 DNS DC2 that's blank. I'll not add DC2 in DC1. I will add DC1 in DC2. I'll tell you the reason why. Because the GTM add script, it tries to pull the configuration of your target. Okay, so I have DC1 DNS is fully loaded with configuration. If I try to add GTM2 here, it will try to pull the configuration of GTM2 that's totally blank, so it will wipe off all the configuration of DNS1. We don't want that, learners. I've logged into this DNS data center 2. Forgive me. I'm a part of GNS for a long, long time, so I normally confuse between GNS and DNS. So I'll log into GNS, DNS data, DC2, and I will try to do a GTM add for uh, DNS data center 1. Okay, let's do that. Okay, it's high time, but before that, let me see if I can 70.1.1.5. Okay, I'm not able to do that. Okay, and I know the reason. It's totally fresh configuration, learners. We configured the, I don't think we created default route, right? So let's quickly add and default route now. It's very simple. Default route, use gateway 80.1.1.1. Okay, now to it again. Okay, cool. From the DC2 F5 DNS, I'm able to ping the DC1 F5 DNS self IP. This is what is needed from the network connectivity point of view. But before that, I also need to configure the synchronization learners, right? Isn't it? I configure the listeners. It's important. Now I configure the synchronization. We already learned this, right? In our previous chapter, the bare minimum configuration that's needed to do a synchronization. You configure the network object, you configure the listener, and you configure the synchronization. So let me do that. Click on synchronization. Our group is test F5. Time tolerance, I will leave everything else default. I will use it as TLS 1.2. We need to make sure that we are using the same TLS version across all the sync group members. And I will check this box that says synchronize zone files. I will leave everything else default. I click on update. All right, learners, so my DC2 is now perfectly ready to be added with the GTM_add script. Okay, so let's do the magic, learners. I will call it magic because I'm pulling or synchronizing the configuration from the active from 0. Yeah. Okay. GTM_add. Again, we use the root credentials to do that. Whether it's big IP add or whether it's a GTM add, we use the root credentials, learners. So make sure you have this handy in the production environment. Okay, and what it's gonna do, it's gonna see. See the note, it says the current master key will be changed, the big IP config will be saved, and it will pull the configuration from the target. Okay, I'll say yes. It will ask for root password, trying to add the certificates. Okay, it's trying to shut down and restart the GTMD. It's trying to add the SSL certs. It's adding it. It'll try to add the name servers, learners. Is it done, really? Are we done with this, or did we forget something? I think we forgot something. Let's see if we can see the sync happened. Okay, cool. But I believe I forgot to add the servers, learner, the self IP. If I check, If I check the server objects here, I could see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay. Okay. As a part of this configuration, it synced the self as well. Cool. Right, learners. I think this is what we needed, right? We wanted a fresh box. We want to add that in a sync group, and we want the necessary configuration to be pulled and make sure that the box is synchronized. So let me check the server objects. Learners, just have a look. Okay, the server objects are synchronized. The wide IPs are the wide IPs are synchronized. Okay, the pools should be synchronized. Okay, perfect, learners. So if I do show GTMI query, okay, it's show. I should be able to see. Oh, there you go. So this is the self, and I should be able to see iQuery established to 80.1.1.5. Okay, it's a second. Okay, great. So you can see I have iQuery established. It shows connected. Server type is big IP DNS. Data center DC2. It is DTCC1. Okay. All right, learners. So we are done with lab overview. We are done with configuring data center 1, data center sync group. We are done with adding LTMs to the big IP DNS. And also we are done with F5 DNS wide APN. Okay, now learners, we are going to do something additional that may not be needed, a configuration on the F5 essentially. But what we are going to do is we are going to set up an authoritative DNS for the testf5.com. So let's pull out diagram, learners. So as I told, the testf5 authoritative name server is this server, and this is responsible for domain testf5.com. So let's try to log in, learners. I will log into this using. I have used one of my GTM as a jump box learner because I wanted to log into that, and its IP is 7113. Yeah. So let's try to. Okay, so this is name server 1. This is my authoritative name server for testf5, testf5.com domain. So this is a bind server, learners. Okay, so my client here, it's not gonna do a DNS query for testweb.gslb.testf5.com. It's gonna query do a DNS query for testweb.testf5.com. We'll see both the scenarios, learner. We will see once the client will try to do a DNS query for testweb.gslb.testf5.com, and we will also try to add some CNAME and try to make sure that we can test it with testweb.testf5.com. Okay, now we are focusing on the DNS part, learners, DNS configuration part. So this is my bind server. So if you check, okay, this is a bind on the Ubuntu. I configured cbdc. So I've already configured a zone for testf5.com, learners. So if you check what all things I have on my testf5.com, okay, I have the A records for. Okay, I've already included the name server for this F5 DNS. So I already told learners, right, this is a pre-configured lab, and if someone wants more in-depth one, I can provide that on a separate video. Please do comment me if you want to have a lab, separate lab for the DNS setup. Okay, so at a high level, let's see what is configured. So normally, what I'm saying here is I'm doing a delegation part, learners. So my name server, my name server one is authoritative name server testify.com, and I'm delegating gslb.testify.com on this server. So let's see how I do that delegation, learners. Okay. I will configure. I have the hosts are this. Okay. So these are the hosts that are outside the purview of my GSLB. So these are directly these hosts are directly non GSLB subdomain hosts. Okay, so they can be referenced with DC1 LO1 service.testify.com. If you want, we can test this as a site. Let's see what's there in my LDNS as well, learners. So this is my LDNS box. Let's see what configuration my LDNS box is having. CD etc bind. Okay, as I said, LDNS is authoritative name server for the fastnet.com domain. And if I check its named configuration, the bind configuration, okay, so it's essentially doing the forwarding for testify.com learners. Okay, it's saying that I'm the master for the fastnet domain, and if any requests come for testify, it will forward it to to the F5. Okay, I need to modify it, learners. I need to I think in my previous lab I tried to forward it to the F5. I just tried to make my F5 as authoritative name server, but here I'll just correct it. Okay, I will make my NS1 as my authoritative name server for testify.com. Okay. Name.conf dot local. Okay, just a small correction. Hopefully it will not take much time. 7113 is my IP address of my or the listener on my authoritative name server. Okay, I'll just try to restart the bind. It may not be needed, but let me reload the name domain. But again, I need to check as well. Okay, hold on a sec. I need to modify the reverse mapping zone file as well, pointing to the DNS server. Okay. Just reload. Okay. All right, learners. So let's open the client machine here. It's again a Linux box. Root. Okay, so as I said, it's already configured to point to the LDNS as DNS. If not, let's do it manually. We are etc resolve to config. Okay, I'll just try to point it manually to our 30.1.1.5. This is my bind server. Sorry, the local LDNS server. So let's see. I mean, I just want to test if my basic DNS is working before I delegate the F5 to the name server one. Okay, so if I try to ping DC1 LO1 dot service dot just f5.com or DC1 LO1 dot service dot just f5.com. Okay, let's see what is the authoritative it's getting. Okay. Sometimes on the emulations it gets a bit slow, learners. Ping 30.1.1.5, it's pinging. Okay, great. You see, okay. Let's see if client router dot hostnet.com. Okay, and why it's not able to forward. Okay, one LO1 dot service dot testify.com. Okay. All right, so let's do some real-time troubleshooting now on the DNS part. It says that it's to try host, so let's try to check the logs. Cat, just say oh, hold on a sec. What is the folder? Tail minus F etc. Oh, hold on. That's where log says log, I guess. Yes. Okay, so I'm just doing capturing of the logs. Okay, if I try to do this, let me see if it's at least getting the broken trust chain and resolving. Okay, it's saying it's broken trust trail. Okay, it's showing us broken trust trail. Let's try to resolve it. Learners cd etc bind cat name dot conf dot. Is it because the DNS validation is not true on it? Okay. Mm-hmm. CG. Gotcha. Okay. Okay. I think maybe I need to add this in under LF transfer, guys. So if I don't add, could have. Why it's not able to forward? It's 20.1.1.5. VI. Okay, so what I will do is I'll just try to remove this line. I'll remove this line. It's going to allow everything by default. Okay, named check conf. Okay, the zones are loaded. Okay, system CTL. They're not needed, but I'm even restarting the bind as well. Learners, so it's very important that we check our for some reason it's dig test fi.com. At 30.1.1. So it's saying the server failed. Okay, so dig is a useful command, learner. So if you want to master the DNS concepts, it's saying the server failed. So let's try to troubleshoot here. Where is our LDNS? This is our LDNS. Okay. Tail minus F. Log. Let's try to enable logging, continuous logging here. Let's try to this. It says that okay, it says that the broken trust chain resolving testify.com. Unable to understand that. 70.1.1.3. What do you mean by broken trust? Catch etc. Get conf dot conf dot local. I'm just trying to forward it. Okay. Okay. So reload system CTL restart bind 9. Named hyphen check conf. Okay. Still says it's so fail. Okay. Let me see if I can see any logs on the name server of here. Okay, so cannot ping. Okay, .1.1.5 here. I can. Okay. Tail minus f. Sorry. etc. Where log. Let's see if I can actually see any logs here. Yeah. Okay, it's certainly falling here, but these logs are of okay. I'll do one thing, learners. I'll just try to reload here. Reboot this LDNS. Okay, till the server comes up. Let's try to see how we can delegate zones, learners. Okay. So what I'm trying to say is we are delegating your gslb.com on our name server, and how can I do that? Okay, just try to open our testify.com zone, and here I've already provided the name server IP. Okay, for all I need to do here is, hold on a sec. All I need to do is I just need to mention origin testify.com. Okay. Mm, mm. At GSLB, that's it. So I just want to mention that GSLB is, I just need to mention that GSLB name server for GSLB here is dc1.f5 DNS with the IP address of the listener. So we mentioned the listener IP address, learner. Okay. Here, let me try to restart the bind. System CTL. Okay. Name. Check on. Make sure the zones are loaded. Okay. Cat. I try to check the bind configuration file here. What I mentioned is okay, it looks good. Check the zone file and see if the delegation is done. So learners, what I want you to understand the two things, okay, what it's meant with delegation. So I explained that delegation is you are authorizing your F5 DNS to be the authorized name server for the subdomain gslb.testify.com, and that you configure it in the main name server. We call it as a glue record. So this is the glue record we create for GSLB, and we point that this is the name server. That's nothing but our DNS server, and we provide the a record for that as well. So let me check if I can just ping it. Okay, sorry. Cat resolve dot conf. Okay, I mean, that may not be needed at this point of time. So in the meantime, let's check if our name server is up, learners. Okay, so LDNS seems to be up. Root. Okay, and the client, let's check. Dig just F5 30.1.1.5. So it's still giving so fail. Okay. Get log. Sorry. Where log. And it's still giving the I'm just wondering if could it be something of DNS sec, okay? This is exactly what I was referring to. So it's trying to broken trust chain resolving test with 5. Okay. Name dot conf dot local options. Okay, let me do here something. Okay, name dot conf dot options, and let me disable the DNS sec validation, learners. I'm suspecting this could be one of the reason. Okay. Systemctl. And I need to do the same on this as well, right? Let's catch the I. So we do RNS reload for every bind change, but don't do, I mean, I don't think bind restart is needed for every change, guys, but I'm just doing it because we are in a emulator environment. CTL. Okay. Let's check. Uh, okay. Oh, there you go, learners. So I think we fixed the DNS issue. So we wanted to learn about F5. We also learn about the DNS as well, learners. Good learning. Okay, so my delegation mode in F5 DNS is also working. So let's see if I can ping a few wide IPs here. Ping test web dot gslb dot test f5.com. Cool. And if I try to web generic host, it should be resolving to the generic host. There you go, learners. So we're learning good. So learners, okay, let me just open the diagram again. So this is my client Linux machine. I'm trying to connect a resource in data center 1 because we have a global availability configured. So if I do a telnet to this web, it should be connected to one of the resource in the data center 1. Let's check that real quick using the DNS name. Okay, learners? Test web dot gslb dot. Okay, so you can see I'm connected to, where it go? I just wanted to, sorry. So you can see I'm connected to SSH server 1. Okay, let me see if I can open up a new window for this. So h192.168.1 dot. Okay, because this looks good, learner. So this actually was not looking good. Okay, so what I'm just trying to do client router. Okay, fine. Try to do this web on my client Linux machine. I can see it's resolving to the web is the primary data center, right? So if I do a telnet, it's connecting to server 1 of data center 1. If I do it again, it should be to the server 2 of data center 1 as we configure round robin at the VIP level. There you go, learner. All right, so my first test is passed. Say for example, my okay, so for example, my core router is down in data center 1. I'm just making my data center 1 down, learners, just to make sure that the wide IP is failing over to data center 2. Okay, I'm just stopping this instance. So that should fail over my my wide IP to the data center 2. But before that, oh, okay, I understood what happened. Okay, not an issue. I can still try to connect with. It should be gone. The connection here is gone because. Hold on a sec. Hold on a sec. But I cannot connect. Okay, I was trying to use this DNS as jump box, but now since this core router is down, I cannot connect from here to my Linux machine, so I need to log in here. Uh, the reason why I'm logging in using the SSH prompt learn is because I believe this VNC console is not that clear. So let me try to use the data center 2 as the jump box. Try to connect here. 2.168.1.2. Okay. Again, I'm connected to the client machine. So if I do a ping, let's see what it's resolving, learners. To ping. It's still not filled over. So it may take a while, learners. I know it may take a while because it's on the emulator environment, and everything under emulator environment takes some time to do a failover. Think bunny on this. Okay, first of all. Okay, first I need to check if I can ping that IP or not. Two 101.1.20 for the client location. Where is this? All right, so it will take a while. It will take a while. 82. Let's check on the client router if I can see the route for this. 784. 82. Two 100.1.1.20. What if I try to connect it from the core router? Oh, for some reason it went down, learners. I've not realized. I tried to shut down the core router data center 1. I've realized that the data center 2 core router is also down. For that reason, the whole VIP was down. But now let's see if the failover happens to data center 2 now. Okay, take a while. Let's see if the convergence happens quickly. We're expecting 7, 8. We have the necessary router. Okay, there you go. I can now. Okay, now ping this. Okay, the convergence is there. Okay, learners. So now my data center 1 is down. So I'm expecting my VIP to resolve the data center 2. Hopefully, my client machine will try to resolve to data center. Okay, I can ping the VIP. Let's say at the GSLB level. It will take a while. Okay. Minus F. I think it's getting timed out. Why it's getting timed out? Let's see. Should be able to ping 70.1.1. Oh, I see the main reason, learners. 70.1.1.3. Okay, I got the. Okay, I got the reason, learners. The reason is our LDNS is forwarding that query to authoritative name. So authoritative name server is also connected to the data center one core router. I forgot that. So I did a wrong failover method. So I need to enable it again, learners. Okay. Sorry for that. So let's see. Now, if I try to resolve it, it should come up in few seconds. Okay. Will take some time, learners. So these emulators are really crazy. That's where there's a difference between emulator and the real production environment. Trust me, in production environment, it should not take that much time. It should be in a fraction of a second, right? Okay, so I can see that connectivity is established. Let's see if my VIP is resolving. There you go. So I can see it's again pointing to the VIP of the data center one. That's primarily because data center one is having the what do you say, the global availability. Okay, let's do the failover test in a different manner, learner. So before that, if I do a telnet to this web, let's see what it's getting resolved. It's resolving data center one. Okay, I do a telnet to, oh, hold on. I just want to make sure that I still have the reachability to data center 2 VIP, yeah. .1.20. Okay, I just need to keep on pinging it, okay. 1.1.20.52. Okay, learner. So at the VIP level, at the IP level, I can see my client is connected to VIP. I mean, it can connect to VIP at data center 1, it will connect to VIP at data center 2. So currently, if I'm pointing to VIP at data center 2, it's connecting me to server 1 at data center 2. Okay, so I'm good here. Now let's do another test, learners. So what I'll do is I'll just try to shut this. Okay, I'll just try to stop this instance. So only the VIP part should be affected, learners. So let's try to see what the resolving happens now. Okay, let me check out the GNS. I mean, or GSLB first. Admin. Okay, the GSLB is saying that the YNAB is up, but it should show one pool as down. Okay, so this is my pool. Okay, as expected, the pool of data center 1 is down. Okay, and if I think it should be okay, give it a time, learners. It will take time to change the where it's getting VIP is up. The pool is down, right? So it should be redirecting pool 2. Telnet. There you go. There you go, learners. So I believe, yep, there you go. You can see now Now the wide app is pointing to data center 2. I think we simulated or emulated the data center failure behavior, learners, but trust me, in the production or in the real environment, you should see it as a fraction of a second. It's just because it's running on EVNG on some heavy emulators. You can see this behavior, but if I do a telnet now and log in, I should be connected to the data center 2 resource here. Okay, learners, I think we covered a comprehensive lab. Part 1, we did the lab overview, we configured data center 1, data center 2. In the DNS sync group, we added the LTMs to the GTMs, we set up DNS wide IP, and we also set up the authoritative DNS for the testify.com and gslb.testify.com. So with this, I'm concluding today's video, and we'll meet soon with the lab part 2, learners, where I would be focusing more mainly on the DNS sec on DNS Express. So keep posting your comments, learners. If you want, I can prepare a separate video and I can walk through the entire lab setup. But for the interest of time, I cannot include all the lab setup in this video. All right. Okay, learners, thank you. Take care and see you soon in the next chapter.